Hello, my friends. My name is Dr. Nayyar Zakazmi. You're watching my YouTube channel. Now, a few days ago, I gave a lecture on Gompertz curves and how Gompertz curves were predicting the COVID-19 growth. Now, in that very lecture on Gompertz curves, I gave a very simple explanation of how Gompertz curves they function and how could we explain the COVID-19 on the basis of those curves. Now, in today's lecture, I will take it a bit further, and I will explain the Gompertz curves in a very simple language to make you understand that how different natural phenomena follow the universal language of mathematics. Now, right from the high school times, when we were studying high school science, like mathematics and physics, we have been told and taught that mathematics is the language of the universe, and every happening and event in the universe can be explained on the basis of mathematical functions. The whole laws of physics, which is the basis of the most modern electrical gadgets that we use, like computers, mobile phones, games like Xbox, PlayStation, is all based on mathematical functions. Now, you can predict your arrival time to a destination if you're going somewhere. For example, if you know your speed by which you are traveling, you can calculate in how much time you will reach to your destination, because you can calculate it with a very simple mathematical formula. And the same goes for many other things. Now, similarly, when we are dealing with the epidemics and pandemics, the same can be explained on the basis of mathematics. In fact, I would say if we look at the discussion surrounding COVID-19 on the electronic media or on the social media, most of the questions are revolving around like what would happen in the future, how will it rise, how will it plateau, how will we flatten the peaks, how many would die, how will it end, when will it end, and so on and so forth. Now, the same discussion has resulted in fear-mongering. It has resulted in wild guessworks. It has resulted in very strange predictions, and so much so that it simply defies an ordinary human mind. Now, honestly, it doesn't require any high-end rocket science to understand this. Statisticians use what we call as regression modeling to predict outcomes surrounding various uncertainties. So in very simple words, if we observe a set of events over a period of time and try to find out the relationship between these events, we can model this relationship into a mathematical formula, which can then give us an estimate of the future events. And this process is known as regression. Now, there is a caveat here. Since we know the future is always a set of random probabilities, so predicting future on basis of regression analysis is what I call as an oversimplified version of reality. Why? Because regression analysis will give you one fixed value, while in reality, the figure can be anything. When we can't actually determine the exact value of future, we use the laws of probability. And we use these laws of probabilities and combine it with the regression analysis, which gives us confidence intervals. And confidence intervals are a range of values in which our future value will fall. So we can say with some certainties that we can have values between these two limits. Now, one type of regression analysis involves Gompertz curves. Now, Gompertz curves, as you all know, were described in 1825 by Benjamin Gompertz after he observed some natural phenomena. And he actually noted that something interesting happened in certain natural phenomena. This strange path is followed by many naturally occurring phenomena, especially in biological sciences, like study of the growth of human populations. And if we study the growth of tumor cell and cancers, we would see that they follow a very strange path. And if these paths are plotted on a time series, we will see that they follow a sigmoid function. Now, sigmoid function is basically an S-shaped curve. So it's a pattern which you get in a form of an S. Now, there are many different types of sigmoid function curves, and one of them is Gompertz curve. So what happens in Gompertz curve? In Gompertz curves, to explain in very simple words, events start out at a very fast pace, and then though apparently they seem like exponential in nature, it seems like they're growing very fast, a careful analysis shows that with the passage of time, the growth factor of the event that we are studying is diminishing. Just imagine, I will give you an example. Just imagine a bullet fired from the muzzle of a gun. Now, the velocity of this bullet is highest at the time of being ejected from the muzzle. And then with the passage of time, the velocity drops, it decreases. Now, apparently over a short distance, it doesn't seem like that to a human eye, because we can't actually determine, all this happens in a very short period of time. But in fact, if you've got a high-speed camera, and if we do a frame-by-frame analysis, this would reveal a very interesting phenomena that speed drops with every fraction of time. $1 million question in this could be, what is causing the drop in the speed with passage of time? Physics students would say, well, this is friction of the air as soon as a bullet is fired. So the friction actually reduces the velocity. And at the same time, there is the action of gravity as well. So gravity is pulling, and that also decreases the velocity. Now, whether it's the friction of the air or whether it's the gravity, both these are what we call as natural physical forces. Now, the same happens in epidemics and pandemics as well. As soon as a pandemic starts, there are natural forces that starts applying brakes to control it. It's all very natural. It could be in the form of changed human behaviors. It could be in the form of innate immune systems. It could be in the form of what we call as environmental and genetic influences, and much more. Now, the whole science of this is quite complex, to be honest. And honestly, it is beyond the scope of this small talk. But this leads to the effect in which a pandemic behaves. Now, if we look at the COVID-19 global figures, both at the morbidity and mortality data, if we have a look at that, we would see that the pandemic is exactly following the Gompertz curves. So everywhere, if you study, it starts at a very fast pace, it shoots up, it feels like it's going to get everybody, and then it feels like it's growing exponentially, though in fact, the exponential growth factor is falling by a small factor with the passage of time till it reaches a plateau. So it stays on a plateau, and then it slowly and gradually declines. Now, many people will argue that, okay, fine, if it reaches plateau, then how comes, like, for example, in the United States of America, it increased, it reached a plateau, it felt like it was falling down, but then again it surged, and they call it a second peak. Now, to understand this, we have to study the events in details. Now, United States of America is a very vast continent. Those areas which were hit early in the course of the pandemic, like New York and Seattle, they got their growth on Gompertz curves, it plateaued and it declined. Those areas where the first wave didn't hit are now getting the same peaks. So it's a matter of time. Somebody gets it in the beginning, somebody gets it later on. Lockdowns or no lockdowns don't make a difference. Like, for example, we take the example of Sweden. In Sweden, COVID-19 has followed the same Gompertz curves without any lockdown, and it was contained successfully. So the speciality of Gompertz curves is that it rises very fast, and it seems that it's growing exponentially. The fact of the matter is that the growth factor starts declining right from the very beginning. And then there is a slow plateau phase which stays for some time. You can call it a variable period of time before declining down to some level.